With our collector ready, let's configure Meraki to send updates to our collector, then validate it using a test script. In order to test this, we need to reserve the Meraki Enterprise sandbox. In the always-on sandbox, we can't arbitrarily add in location service receivers, but we can within a reserved instance. I currently have this reserved, so let's jump over to the dashboard. DevNet will provide login instructions via email, and I've already logged in, so let's navigate to the Location API configuration. First, we highlight the network-wide category, then under Configure, choose General. Scrolling down, we see the Location and Scanning section. Ensure that both Analytics and Scanning API are enabled, then note the validator. This is the string our HTTPS server needs to send back when Meraki issues a GET request. I've ensured that this validator matches the constant in our code as indicated by the screenshot. Next, we can add our post URLs, which is where Meraki will send location data. I'll fill in our URL and secret quickly. Now we've specified the correct URL, the correct secret, and the correct API version. Clicking Validate, Meraki will send its GET request and ensure the validator matches. Okay, our server was successfully validated, which means our Flask app and certificates are functioning correctly. Every time Meraki sends a post request in the future, the HTTP body will contain the secret that our server will verify. Let me save the configuration changes before we move on. I'll scroll down once more just to verify our changes were saved. Okay, that looks correct. Let's check our HTTPS server logs next. We see there was an HTTP GET request, and this was Meraki performing validation. At this point, we are done, but it's difficult to test since we don't have any real wireless clients. Let's head to the dev box. I wrote a small test script named senddata.py to simulate Meraki. Basically, this script is going to spoof post requests to our server pretending to be Meraki, so we define the validator and secret first. Next, we load in the data.json file we explored in the previous clip. We'll use this sample data as our post request body. I then issue a GET request, just like Meraki, to ensure that the server's validator is the same as the one configured locally. We already know this works since we successfully integrated Meraki with our receiver earlier, but this just confirms it again. Assuming the validator matches, we update our data dictionary with the secret constant defined earlier. Remember, our receiver is expecting the secret with each post request, otherwise we'll get an HTTP 401 unauthorized response. This post request and associated header dictionary should look familiar by now, so I won't dig into it. Assuming the request succeeded, I perform one quick check to ensure the messages were transferred successfully. If you recall, our HTTPS server returns a dictionary containing the number of observations received, so our test script can validate it. Basically, it's like the server saying, I just received 2 observations, then the client saying, that's correct because I sent you 2 observations. I assert that both sides agree on the number of observations transferred and print a log message to prove it. The rest of the script is just error handling, such as printing the HTTP status code and reason if the post request fails, or revealing any potential validator mismatches after the GET request is issued. Let's run the senddata.py script and ensure the HTTPS server can process it. Okay, it says we sent and received 2 observations, so let's check the HTTPS server logs. The server just prints out the received JSON data, which appears correct at a glance. I realize this is kind of lame, but it's the only way I could think of to test location data. If you have real Meraki hardware with wireless clients, you can use this HTTPS receiver in your environment for location data collection. I didn't want to assume that viewers would have access to that equipment, which is why I wrote this script, which you can use for educational purposes.